Hi, thanks for having me. I'm excited to be here. My name is Peter Johnson. I am a co-founder and lead of the research team at Zapata Computing. I'm excited to tell you a bit about Zapata, the work that we're doing, our culture, and also why I almost didn't join the company. So before we get to that, though, what is Zapata? So at Zapata, we are building software to make quantum computing useful. So everything that we're doing is driving towards achieving quantum advantage. And so we like to think that while hardware companies like Honeywell are driving their devices towards quantum advantage, we are taking quantum advantage and pulling it closer to the devices. And so a brief history of Zapata. We launched out of the Harvard Chemistry Department in late 2017, early 2018, and set up headquarters in Boston. In 2019, we set up our office in Toronto, and we began work with our first set of customers where we were using our internal platform that we built to carry out these quantum research projects and using quantum computers. In 2020, we launched this internal product as our first external product called Orchestra. And this is a workflow management system that makes quantum computing more accessible to enterprise teams. So I'd like to tell you a bit about our culture. We say that we are curious, creative, and revolutionary, but okay, what does this mean? So I thought it would be more interesting and fun if I told some personal stories about Zapata. Yeah, I guess, wow, I miss using chalkboards. Okay, for the first story, I started as a postdoc in 2016 in the Alana Spurugusik group in the Harvard Chemistry Department. And I found myself surrounded by these brilliant, kind, welcoming people. And I was excited to learn about quantum algorithms and work with these people to develop some of our own. And I had always wanted to have a career in academia. And I found myself in a very fortunate place to be able to launch this career. And I was excited about this career in academia in order to start a research group with fun, creative people to work on important problems and help people advance their scientific careers. And so when the first summer of my postdoc came around, I started applying for faculty positions. And I was about 2 weeks into this process when I was sitting at my desk one afternoon, and Alana Spurugusik and another postdoc in the group, Johnny Olson, burst into the office and announced, "Everyone, we are going to be starting a quantum computing company. Who's in?" And so I thought about how I had been putting all of this effort into these faculty applications. And so it seemed crazy to me to switch gears and start trying to build a company. And so I actually said no. And over the next month, I continued with my applications and had a number of conversations with people in the group about this company and what it would be like to start a quantum computing company. And through these conversations, I came to realize that this joining industry would give me an opportunity to build a group of fun, creative people solving important problems and creating opportunities for people to advance their scientific careers. And moreover, this institution would be a group of people all working towards a common goal. And so with this realization, it became obvious that this was the right choice. And so I decided to join Zapata with these people. And it's kind of terrifying to think back on that decision. And I think if I had said no, I probably would have died from extreme FOMO at this point. So who were these people that I was so excited to work with? So one of these people was Hannah Sim. And I have a quote here from Hannah about her experience working at Zapata. Hannah says, Zapata is very supportive of its team members, especially towards junior scientists and engineers. Questions and ideas are always encouraged and welcomed, with everyone being respectful of each other's learning experience. So Hannah joined Zapata as an intern in the first summer, and I was lucky to work with Hannah on a research problem that eventually gained a lot of interest. And so the problem was, how do we design quantum circuits to be useful for near-term quantum computing? And so Hannah developed a methodology over that summer for assessing how expressive quantum circuits could be. And she published this work in AQT in the fall of 2019. And through this experience of working with Hannah, she explained to me a number of very interesting parallels between quantum circuits and neural networks in machine learning. And one of these ideas she developed into a method that borrows techniques from machine learning to help optimize quantum circuits. And so bit by bit, Hannah has been putting together this research program geared at answering this question of how do we design near-term quantum circuits to be practical for different applications. And so I'm excited that Hannah will be joining Zapata as a full-time research scientist in this April. And I know she's looking for bright interns, so if you're interested, please see us at the career booth after, and please visit our website to see our various career opportunities.